All right, I guess we'll get started. Hello, this is Demystifying Terraform, a hardcore to core infrastructure as code tool. Early in the call for speakers, requests, there was a blog post, I think, on PowerShell.org, listed a whole bunch of topics that were interesting to people, maybe suggestions, and one of the suggestions was maybe not hardcore topics like HashiCorp tools and some other stuff like that. Well, I personally don't think HashiCorp tools like Terraform are hardcore, so I went ahead and submitted a talk, and I guess at least a couple people agreed with me. And so here we are. All right, so I'm not here just to convince you to drop ARM or something for some new hotness tool. I think ARM is it's a good tool for what it does. Terraform is just another option in the infrastructure as code sort of tool set. So hopefully as we go through this, I give you enough information to maybe make an informed decision about looking at or maybe you're just like, nope, I'm good with ARM or CloudFormation, or hopefully not just like running ad hoc scripts in Cloud Shell, or even worse, using the portal. Don't do that. All right. So some context. I'm a SRE at Stack Overflow. If you've attended my other session, I talked about how I work on the enterprise product, and whenever we bring in a new client, that means standing up new infrastructure from top to bottom. So every customer gets their own independent infrastructure. So that means we create a lot of Azure infrastructure. And that's, well, why we definitely are doing infrastructure as code, because if we had to do this through the portal or using just scripts sitting at the command line, we'd screw it up almost every time, at least one way or another. So when I started at Stack Overflow about a year ago, we had a nice ARM template. It was about 2,000 lines of JSON. I looked at it for a couple weeks and really couldn't figure out what the hell was going on. And even worse than that, whenever we wanted to make a change, we were kind of terrified, because the way you figure out what's going to change with ARM is you apply it, see what happens. And then finally, the ARM template made a lot of assumptions about how we were going to build our infrastructure from now until the end of time. As you may have known, if you work with Azure, names are kind of important. So in the AWS world, you can provision infrastructure and you get a nice little unique ID for everything, and names are just metadata. But in Azure, a name is part of the ID. So you can't just stand up 50 VMs all called my web server. So the ARM template didn't have any way for us to basically stand up like 2 instances for a customer. Say they want a test site and a production site. Well, they can't both have web server 01 and 02 because those are unique IDs in the Azure world. So we were going to have to rebuild this ARM template to add some functionality. And after I looked at it for a few hours, I just decided no. I was really interested in Terraform. I've used Terraform previously to do AWS stuff, so I was pretty comfortable with it. And one other really important feature at the time when we were looking at this, you could not create resource groups in ARM. So if I wanted to create a bunch of resource groups, that meant I had to had some orchestration that created the resource group, then called the ARM template, passing in the resource group, blah, blah, blah. With Terraform, I can encapsulate all of that in a single command line. So that's me. We're kind of a unique case. Terraform makes a lot of sense for us, but why would you be interested in using it? And I think one of the biggest selling points is there's a lot of community and commercial support behind Terraform. A lot of great open source projects, commercial projects have first-class support for it. TerraTest is like an open source infrastructure acceptance testing framework written in Go. Doesn't work great for Azure stuff, but it's a really great open source project. Atlantis was an open source project for running basically a Terraform like apply in a test environment for every Git like PR. It would run it and then just post back what changed into the PR. You could accept it as basically like a GitHub bot for Terraform. Octopus Deploy has native support for Terraform. You can just, it knows how to work with Terraform and deal with Terraform input and output. And then a lot of CI/CD pipeline tools, platforms, they're all just pretty much treating Terraform as a first-class citizen. So yeah, of course you can make ARM work. But again, if you're trying to figure something out, why not just stand on the shoulders of giants? There's probably already a lot of examples out there. The other really big advantage is you can use the same tool set to work with a whole bunch of cloud providers. So this is not just Azure, AWS. There's like 100 different various SaaS providers. So one cool scenario is you can stand up some infrastructure in Azure, and then you can wire up your alerts to PagerDuty all within the same Terraform config. Or you can configure some Grafana dashboards, or just more combinations than I can even imagine. And that's just all the published ones. There's plenty of undocumented sort of just open source providers floating around GitHub and stuff. And then also, just so you think, nah, Microsoft's not really concerned about this. They have ARM, they're good enough. They are invested in this. They've literally invested millions in funding this. They have teams in Microsoft working on the Azure RM provider. And if you don't believe me, you can go talk to Mark Gray. He's the program manager for the OSS. He's blogging frequently about updates coming out for this project. So it's okay to invest in. I don't think you're going to get abandoned anytime soon. All right. So that's pretty much all my slides. And I'm about to get into demos. But before I start on demos, I wanted to give a few disclaimers. One, my demos are made up. Don't do these at home. This is not good examples of how to do any kind of best practice infrastructure. Our typical Terraform run for a client site is around 150 resources and takes 45 to 50 minutes. So if we kicked that off, we would all leave. So I picked a couple really cheap, simple resources that we can stand up and mess around with. I'm just demonstrating really the functionality of the language and kind of get you used to thinking about configuration in Terraform. The other caveat is my demos are focused around Terraform 0.11, which is the current release, but 0.12 is in beta 2 now. Sort of just around the corner, and it's also a pretty significant update. They actually major revision on the underlying language. So there's a lot of new functionality. There's for loops. There's some better support for things. But 11's what I'm used to. So I've been working on this for a while. 11's what my demos are. So just know if you go looking some of these up in Terraform documentation, at the top will say this is for 0.11 or 0.12. If you're looking at 0.11, click here. So there may be some variation if you go looking up kind of documentation on these examples later. All right, let's see. All right, is this good for everybody? I hope. If I have to go bigger, I probably won't be able to fit anything on the screen. Let me control this and show you. So to create a Terraform config, this is pretty much all you need. One file with a TF extension, and basically two kind of nodes. A provider that's telling you which cloud provider, which SaaS provider you're messing around with, and at least one resource. I guess technically you don't even need a resource, but that's kind of the point of this. A resource is basically some kind of cloud object. So in this case, it's representing an Azure resource group, and I give it a name and a location. So simple enough. Now, what do you do with that? So the first thing you have to do for any config in Terraform is you need to initialize it. So what this is doing is going out to the HashiCorp site. It's saying, OK, you're using the Azure RM provider. Let me go download that for you. And it pulls it in locally. You can see up here, I now have this .terraform folder. And that's where my plugins exist. So from now on, I don't have to do an init unless I actually want to change something or delete this folder. So that's how you get started. The next thing you probably want to do, and this is, again, one of the big selling points for me using Terraform over ARM, this Terraform plan. And this is going to look at my files and try and estimate as best it can without actually doing anything what's going to change on my system. And since this is a new site or new configuration, everything's changing, which in this case is I'm creating one resource. And you can see in the plan, it's listing a plus is create, and then at the end it summarizes it. So I have one thing to add, 0 to change, 0 to destroy. You can kind of ignore this stuff for now. We'll talk about that later. So that's the plan. Looks good to me. I'm not doing anything too crazy. So let's see what actually happens when I try to apply. So this is not like ARM where it's going to throw a blob of JSON out there. This is actually going to call individual APIs in a proper order. And it's not usually this slow. I'm guessing it's Wi-Fi. OK, so this looks like the plan. It's basically ran the plan again, and it's asking me, are you sure you want to do this? And there it goes. So it actually created me an RSG. Says it looks good. So let's see if, there we go. So I now have this Summit 2019 resource group. Simple enough. Now you probably want to do a little bit more than that. So let's get a little bit more advanced. So now you can see we're adding a few more files in here. And it doesn't really matter what you call these. Convention is main.tf, output.tf, variables.tf. But actually, Terraform doesn't care. As long as you have a .tf extension, it's going to look through those and figure out what's included. So the big thing we added here, this variables.tf, is all of our variable definitions. And if you've used ARM templates, these are like parameters. This is how you get input from, I don't know, the person running it or your CI pipeline or something. Well, this is how you're going to provide variables so you can sort of abstract out your configs and you're not just creating a config for every possible variation. And so you can see the simplest definition is just variable and a name. You don't have to give it anything else. But then you can get a little bit more advanced. You can provide a description, helpful for your users. And you can also provide a default value. And if you provide a default value, Terraform will infer the type of that value based on the default. So if you give it a string and then you try and pass a hash later, it's going to say, no, sorry, not what I was expecting. And then you can get really specific, and you can actually define the type. And this is the syntax for defining a map or a hash table. So the current version of Terraform supports 3 types: strings, lists, and maps. You notice that there's no numerics, there's no booleans, but we'll talk about that later. All right, so let me show you what I've already, so you can see I have the .terraform folder. I've already done a Terraform init. What's that? Oh, thank you. Oh, and this takes forever. So it's actually kind of just a waste of time to hit Control-C, but it's habit. So you'll see that Terraform sort of treats parameters like PowerShell. And if you don't supply a value, it forces you to give it a value. So give a value, and then voila. This basically works the same. Now, the other thing that we had in here is output. And this is things you want to spit out of Terraform. So again, this is sort of a made-up thing. And when you run your apply, you're going to see the resource group ID anyway. But imagine you have like 150 resources, but there's a few things you want to actually get the value of, like resource names or computer names, or like a storage key, something that's computed. So you can use this output to basically pass it along to either a user or another system. But, oops, not there. If you run Terraform apply, you'll see output at the end. Oh, well, I have no outputs. OK, then let's try this. Do I have, yeah. I feel like we should have elevator music. All right, so yes, I want to apply that. So you can see ID is computed. There's no way to know ahead of time what it is. Well, that's not true, because we all know how Azure IDs are computed. But so there you go. My output is shown at the end. I could consume that by some other automation, but I can also grab it later by using the right command. And so this will list any outputs from your previous run. Now, I said earlier that you can kind of name files however you want. So this is a really good example of a bad example. So here, it's a single Terraform file. I've got variable definitions, provider, output, resource, another variable. It's all in one file. This technically works. Terraform doesn't care, but I do. So please don't do it like this. Just break out your files into something that's meaningful to you, because if multiple people are working on this in Git or whatever, if everybody's working on this same file, you're just going to merge conflict hell. So like I said, this basically does the same as the last one. It's just a really bad way of setting things up. All right, so another form of variables in Terraform are locals. And these are sort of like ARM variables. So you can, well, this is actually a terrible example, but you can dynamically, come up with some new variables. These are scoped specifically to this variable, so you can't supply them from the outside. You can't do anything else with them. And then the other thing that we're doing here is this data resource is another form of basically a way to pull in data from some external system. In this case, we're just pulling it in from Azure itself again. And what I have is an existing resource group. Say I'm trying to add, new infrastructure to an existing resource group, and I don't want to necessarily create one, but I need to know something about it. I could go, copy the information, the name, location, whatever I want. But this data resource will go out to Azure, read the configuration of that resource group, and then I can then reference bits of that later in my configuration. I think it's getting slower. OK, so let's scroll up and see what's actually going on here. Oops. So you can see the plan again. It would create a new storage account. But what it's doing, you can see, first it's going out and it's reading this resource group and grabbing data. And that's how we're going to populate the location for this storage group. So you could use this for a bunch of things. Like I said, if you have existing infrastructure, you could read from that. If you have another service provider, maybe that's providing DNS or something, and you want to pull in information from that service provider, that's a way you can, again, you can link these up to build up your infrastructure. All right, so in this example, we're going to build a module. So one of the cool things also about Terraform is really creating modules is super simple. You don't have to necessarily do anything. You don't have to package them up. You don't have to give them funny versions. You don't have to reference them through some complicated URL. The simplest way to do a version is you just create a folder and you throw in some .tf files. So this is basically copied from the previous example. We're going to read from a resource group, create a storage account. And what we're doing is sort of abstracting out some components. So we can sort of create an API between bits of our infrastructure. So I know this storage account requires an RSG name and a prefix. If somebody else were to use this, they don't necessarily need to know what's going on in this module. They just need to know, I need to give you an RSG name and a prefix. So kind of like PowerShell module, you can package up some logic. You don't necessarily have to understand what's going on. Don't download it from the internet and just assume it's going to work for you, though. But good for sharing around. So this is what it looks like in the main. So we're just calling a module. You give it a name. And in this case, my source is just the local folder. Yeah, I guess. Nope. Actually, let me show you this first. In this case, I did not do an init because I want to show right here an important part of that init phase, besides also going out to the internet and grabbing the provider, is pulling in the storage module. Now, important thing to know is when it's doing that, it's creating a local copy. So this is a copy of that module. If you make a change to this module and you don't do Terraform init again, you're just going to be running off this same cached module. So even though we're building this locally, if you don't run Terraform init again, you're not pulling it into the working configuration. So now that it's in, I thought I picked the fast ones, sorry. All right, so again, I mean, this doesn't look too different, but now you can see we're referencing this storage module. It's a slightly different naming scheme, but underneath the covers, it's still going to provision the same infrastructure. So this is one of my favorite examples. So there's quite a bit going on. And if you remember when we were talking about variables, there's a few different types. And none of them are Boolean, except in this case, I've defined the default value for second site as false. And you can see VS Code isn't highlighting it as a string. It seems to think it's an actual value. And then down here in this definition for a second resource group, I'm passing the value of that second site to a parameter called count, which, I don't know. Usually it's a number, but we're going to pass it a Boolean that technically there isn't support for Booleans. And to even make it more complicated, well, let's actually do this first. So by default, this is what happens. So in this case with the default value, false actually gets interpreted to 0 when I'm passing it over to count. And what that does is one of the hacky ways in Terraform to basically create a conditional resource. So you can pass a false to a count or a 0 to a count, and that resource it doesn't get created because there's a count of 0. Now, if I want to create the second site, you'd think, okay, I can pass true, except if you're passing variables through the command line, you can't pass the string true because it's not really a string. It's sort of like this made-up interpolated Boolean. So in this case, you have to pass the value 1 for true. And big surprise, what it's going to do is create the first and the second resource group. So here you go. See, 2 resource groups. Yay. Now, the other weird thing is, like I said, Booleans don't exist, so it's not really typed as a Boolean. And I can pass basically anything that count will accept, so any number. And this is going to do something also very interesting for configurations. So the count is a way that you can, without declaring like individual resource nodes, you can just create a bunch of things. So I could pass in 100 and get 100 resource groups. And it's using this built-in property, count.index. So every time it creates a new one, you're just going to get an incremented value here. You can add that on as part of that string, and you're going to end up with a whole bunch of these. Okay. So let me jump over to this one. And again, this is not another useful example. Like, don't think this is how you should define any kind of Terraform config. I'm just trying to show some of the functionality of working with Terraform. In this case, again, I'm creating some stuff, just a local file with a random string as the contents. I'm going to read the file and pass it out. This one, hopefully, it's pretty fast. It's all local. Maybe not. So up here, I'm creating a random string. I'm passing that random string to the contents of, creating a file, reading the file, passing it as output. One thing to point out here is you can define an output as sensitive. And what that does for you is now Terraform is going to hide that running the output. So you're not accidentally, oops. Not that button. Putting secrets to the screen. Oops. However, if you want to get to it, you can run Terraform output and get it. It's all there. So let me show you, since we've been talking about it, or maybe not so much. So another big difference of Terraform is it keeps track of the state that it knows about. And this is a state file that it's creating locally to keep track of things. And you can see here's my defined outputs, here's my resources, all the attributes. And you see nothing's blanked out, it's all there. So an important aspect of Terraform is keeping your TF state files secure. And to do that, what I suggest is instead of storing them locally, oops, sorry, I'm getting ahead of myself. We'll talk about that next. This is an example of just pulling down a module from the repository. So HashiCorp maintains a public repository of published modules. There are several Azure modules. So this one actually creates a network, stands up some subnets, and just like the previous module, it's kind of abstracted away behind these values. Another important part of these public modules is you can pin the version, which is a good idea. So instead of just taking whatever kind of is latest on the public repository, if you know 2.0 is the one that works with your infrastructure, stick with that until you actually test out the new one. So if you run this over and over again, even if they publish a new module, you're not going to grab that until you update this version specification and do another Terraform in it. Okay, so this was what I was talking about for your state file. So by default, Terraform is just going to drop the state file in the local system, but it has support for what they're called Backend Providers, and Azure RM is a valid backend provider. And what that is really just a way to write state to hit it. Some blobs. So I've already set this up. There's a blob out there called TF state, and there's actually state in it. So to do that, create your storage account, create your blob, and you need to somehow pass this into Terraform. You can either do it at the command line like a variable, or you can create this backend TFR. You do need to know the access key, and don't store that in this particular file. That is something you want to pass through some environment variable or something that's a little bit more secure than just sticking it in this file and checking it into Git or something. So in this case, state. I've not initialized it. Okay. Oh, sorry. Oh, no. Blah, don't do this. So this is telling Terraform to use the backend configuration. So now it's going to store Terraform, or it's going to store the state there. By default, Azure's using encryption at rest on these, so that's good. But you also still need to make sure you're locking it down. Don't give everybody just read access to this state file because, like I said, if you end up configuring some secrets, they're going to be accessible there. You really want to limit this only to, say, some automation that can create provision infrastructure. Okay, and let me jump to this one. So did anybody attend Brandon Olin's talk on Saki? Okay, so don't see. This should look a little bit familiar then. So I actually stole this from him. He built it. And this is some automation that we're using to automatically test and validate modules. So one of the things about building Terraform configs via modules is you can sort of unit test them. So I don't have to build all 150 resources and go through and make sure everything works. I can test this one little storage module, make sure it works like I expect, and then going forward I know, okay, like this passed the tests, I'm good to use it. I don't have to necessarily understand what's going on. So I'm not going to go through all of this. Hopefully you saw his talk, or if not, you can grab it when the recording comes out. But this is just running the Terraform init. It's running a Terraform validate, which does some kind of linting. It's going to run a plan, and then it's going to run apply. And that's going to create my infrastructure. And then it's going to run invoke Pester. So over here we have just a few Pester tests configured. So hopefully this looks fairly familiar if you've done anything with Pester. So there you can see it's run through init, ran through validate, didn't find any issues. So now it's running plan. And one of the advantages, if you run plan, you can save the output of that plan to a file, and you pass that as input to apply, and you don't have to go through the whole, like, yes, I want to do this. So this is the best way to do it through automation. So it's building out my infrastructure now. Go back to my resource groups. There we go. So it created some random named resource group. Maybe putting stuff in it. Yeah, so it's created the storage account. There's the storage account. And now it's kicking off Pester. So it's going to run and just make sure the module created the things I wanted it to create, created them with the parameters that I wanted to create. In this case, all 3 tests passed, yay, and now it's going to tear it all down. So we run this in our CI pipeline, and every time somebody does a commit, now we get automated testing of these modules. So you can see in Azure DevOps, it's the same output. And we even get really cool graphs and things about tests, so we know it's working. And the history, of these tests. So that's all I got. Hopefully that was helpful. If you have any questions, yes.
Yeah, is it possible to create an internal module repository?
Yes, that's an excellent question. Is it possible to create an internal module repository? And yes. So there are not any commercial providers that currently that I'm aware of that provide sort of commercial off-the-shelf support for Terraform modules. But the Terraform module syntax has support for reading from Git, either a Git branch or even a GitHub URL. So you can create, and this is how we actually do it at Stack Overflow. We just we tag a particular commit as a version, and then that's what we specify for the module source. Yep.
Where did you do the connection to Azure from the beginning? Where do you
Okay, so yeah, the connection to Azure. I didn't show it because it involves credentials and stuff. But here, let me show you. So first, I have a little snippet. Create service principal. You need to give it contributor and scope it to what you want access to. And then you need to but that's going to show things that I don't want you to see. But so basically, you have to provide these. I don't know if you've created a service principal before, but you get a client ID, you get a tenant ID, you get the secret, and then you need to supply the subscription. So if you create those 4 environment variables, the Terraform documentation tells you the syntax. It's basically arm underscore those things. And then the arm provider knows how to read those and connect. Right? I guess we're out of time, so thank you very much.